Uh, so today we will discuss example problems in design of isolated footing under uniform pressure. Okay. So example 1, a square footing which is 2.4 meters by 2.4 meters with a thickness of 0.45 meter thick supports a rectangular column of 0.35 by 0.4 at its center. Okay. The column loads at service condition, meaning unfactored loads. We have 680 kilonewton dead load and live load of 400 kilonewton. With the compressive strength of concrete, it has 20.7 and Fy of 275. So the concrete cover to the centroid of steel reinforcement is 100 millimeters and use a factor of safety of a reduction factor 0.85. Okay, so this factor is from NCP 2001. Okay, that is why the load combination is 1.4 dead load plus 1.7 live load. Okay, so we want to determine the maximum wide beam shear stress, the maximum punching shear stress, and the number of 20 bars for critical moment. Okay, so let us start. Dito muna tayo. Number 1 is the wide beam shear stress. So before we start, tingnan muna natin ano yung foundation natin. Yung foundation natin, we have a 2.4 meters by 2.4 meters with a column of 0.35 by 0.4. Okay, this one. This is your 0.35 and this is your 0.4. Okay. Then we have a thickness of yung total depth H is equals to 450 millimeter thick. And a steel cover. Okay, steel cover is yung cover ng ating foundation to the center of reinforcement. Okay. So this is 100 millimeters. Okay. So to determine number 1, to determine the maximum wide beam shear stress. Okay. If you recall, the location of the critical wide beam shear stress is at a D distance from the face of the column. Okay, so saan ba yung D distance dito? Ano pa yung D muna natin? Yung effective depth. To determine the effective depth, ito yung total H. Okay, total H minus the steel cover. If you recall how to determine the effective depth in your reinforced concrete design. So this is 350 millimeter. Okay? Then after that, pwede na natin sukatin yung D distance from the face of the column. So saan ba yung D distance na yun? So ito yung ating foundation. Ito yung 350 by 400. Okay. So sukatin natin yung D distance from the face of the column. So pwedeng ito. This is your D distance. Or pwede rin ito. This is your, okay, ibang kulay. This is your D distance. Okay. So let us determine the dimensions. Alapin lang natin yung dimensions. So ito, this one is 2,400. This one is also 2,400 millimeters. Okay, and the distance is 350. So, para malaman natin yung length nito, okay, ang length nito, should be this one. Okay, also this one, and this one. Okay, kunin natin. Nakikita nyo ba yung 991ES? Yung calculator? Okay. So, hanapin muna natin tong distance na to. So, tama ba na that is 2,400? 2,400 minus yung column dimension, which is 350. So, yan yung sukat ng dalawang ito. This one and this one. So, divide nyo lang sa 2, you have your dimensions, which is 1,025, 1,025. Next, doon naman sa isang side. Doon sa isang side, that is 2,400 minus 400 divided by 2, you have 1,000. So this is 1,000. This is 1,000, and this is 1,000. Okay. So therefore, yung length na to is 1,025 minus d, and this is 1,000 minus d. Okay. So, tama ba na ito yung mas malaking area? Kasi 1,025 to eh. So, therefore, this will be your critical wide beam shear stress. Yan yung, dito yung mag-produce ng largest area. Because 1,025 is greater than 1,000, and yung distance na to is mas malaki dito. Mas malaki yan dito. Okay? So, ano ba yung distance na yan? 1,025 minus 350, that is 675. 675 ito ay 650 lang. Okay, so ang area nito is 675 by 24, and yung area ng green is 650 by 24. So, mas malaki yung 675 by 24. Okay, so therefore, ito yung ating consider. So, kung kukunin natin yan, that is ito. Isolate natin. Okay. So we have a depth of 350, a length of 2,400, and dimension which is 675. Okay. So remember, since this is a actually loaded footing, remember that you have a uniform pressure assumption at the bottom. Diba may uniform pressure tayo dyan? And if you recall that uniform pressure Q sub U is equals to PU over area. So we need to find your PU over area. Yung PU natin comes from the load combination 1.4. What is our dead load? 680. Our live load is 400. Okay. Divided by 2.4 by 2.4. It should be in meters. So convert ko na lang to in meters. So this is 2.4. This is 0.35 and this is 0.67. Okay. So this will be, your QU will be, ano ba yung QU natin? I-open ko lang calculator. So that will be 1.4 times 680 plus 1.7 times 400 divided by 2.4 by 2.4. This is 283.33. That is 283.33 kPa. Okay, so now we need to determine that load, yung shear force VU. Ano yung VU? VU sub W. Okay, ano ba hinahanap natin? Nominal? Hindi naman. Okay. To determine that the VU sub W, basically that is yung pressure sa ilalim multiplied by yung area of contact. Ano ba yung area of contact ng soil sa ilalim? Yung area of contact ng soil sa ilalim, that is 2.4 by 0.675. So therefore, your VU sub W is equals to 283.333 multiplied by 0.675 multiplied by 2.4. Again, yung VU sub W is yung stress times area. So, yung stress mo sa ilalim or yung pressure mo sa ilalim is basically yung QU mo. Okay? Pero ano yung area? Yung area is yung contact area to the soil. Yung contact area sa soil, ito. Ano ba yung magko-contact dun sa soil? That is 0.675 by 2.4. Okay, therefore, this is 283.333 multiplied by 0.675 multiplied by 2.4. You get 458.999. 458.999 kilonewton. Okay. Then, if you recall the formula for the shear stress, okay, your shear stress W, T tau sub W, is basically kung ano yung force divided by dun sa shearing area. And the shearing area is what you have over here. Ito yung shearing area, di ba? Yan yung magkakos ng shear dito sa part na to. Okay. So, very straightforward. Kunin mo lang yung force, divide mo dun sa shearing area, meron ka ng stresses. Okay, however, you need to use the factor or the reduction factor since dapat naka-nominal tayo. So that is 458.999. Divide it to what you call this, yung shearing area. So yung shearing area natin is, tama ba na that is 0.35 meters by 2.4 meters. Or kung check nyo yung ating formula natin is tau sub W is equals to VU sub W over phi BD. Okay, yung B natin is 2.4, yung D natin is 0.35, and yung phi factor natin this time is using NSCP 2001 which is 0.85. Okay, so let us divide it to 0.85, divide it to 0.35, divided by 2.4. Get 600, should be 642.856 kPa. Bakit kPa? Kasi kilonewton square meters yung ilalim, that is kPa. And approximately that is 0.6 MPa. Megapascal. I think naka-megapascal yung answer choices. Should be, so 0.64 pala. Okay, so that is this one. Okay, they have questions for maximum wide beam shear stress. Okay, so meron ka ng actual shear stress or demand shear stress. Now compare it to your capacity. So if you recall the capacity, that is 0.17 lambda square root of F prime C. Yan yung stresses. Okay. Okay. After nun, compare mo sila, sino yung mas mataas, sino yung ano. Kapag mas mataas yung demand, meaning mas malakas yung bubuhatin ng ating footing, therefore fail yung footing natin. Pero mas mataas yung capacity, meaning kaya niyang i-carry yung that load. Okay? So next natin is number 2, the punching shear stress. Okay? So if you recall yung punching shear stress, the critical dimensions or the critical section is at a d/2 distance from the face of the column. Now it should be this one. So d/2 distance daw eh. So that is, ito yung column mo. Okay? So sukat ka d/2, d/2 kabilang side, d/2 kabilang side. Okay. And this distance is C1 plus d/2 plus d/2, that is C1 plus D. And this side is C2 plus D. Okay. So C2 plus D. Okay. And again, this length is your 2.4 meters and this length is your 2.4 meters. Okay. Then ang tendency, this will tear apart. So yung mapapunch siya eh, parang puncher. If you, kung parang i-consider mo siya as puncher, yung itong inside is mapapunch out. Maiiwad yung itong nasa labas. Okay, then so let us determine muna yung C1 plus D and C2 plus D. Okay. Yung C1 plus D, that is 0.35 meters. Ito yung length na to. Plus mo ng effective depth. Your effective depth is 0.35 din. Okay, that is 0.7. And yung kabilang side, that is 0.35 plus 0.4, that is 0.75. Okay? Tama ba? 0.35, 0.4. So that is 0.75. Okay. So, if you recall yung binigay ko sa inyo formula for determining the shear stress. So, drawing natin ito muna. Isolate natin ito. Okay, kasi daw magpa-punch yan eh. So, isolate natin yan. Kung i-isolate natin yan guys, this is your C1 plus D, C2 plus D. Okay, lagyan na rin natin ng column para mas madali nyo makita. Lagyan natin ng column. So, straight dito. Ito nakikita. Yan. Yan. Okay. Then you have your yan. So, meron tayong depth. Okay. Ang distance na ito, that is 0.7. That is C1 plus D. And yung distance na ito, that is 0.75. And yung effective depth is 0.35. Okay. Right. Then, sulat natin yung sa ilalim. Drawing natin sa ilalim. So, yung nakikita dito. Wait lang. Ito yung kulang ito. Taasan ko pa siya. Yan. Doon sa kabilang side. Yan. Yan. Okay. Okay. So, kailangan nating i-determine muna yung VU sub P. Okay, yung VU sub P. So, kung babalikan natin yung ating slides, okay, this one, where is our, okay, your VU sub P, ayan, so, meron pa tayong settings. Okay, this one is your VU sub P, right? So, determine that VU sub P, okay, balik tayo dito. Okay, to determine your VU sub P, yun yung force na magkakos ng punching, yung shear force that will cause punching, that is your VU sub P. Yan. That should be in the center. Okay, it should be in the center. Okay. So, ayan. So, ito yung magkakos ng VU sub P, yung punching dito. So, to determine the VU sub P, di ba may iwan ulit ito? Okay, may iwan ulit itong area na to. This will contact yung soil. Ito yung magkakaroon ng contact dun sa soil, sa ilalim. Tama ba? So, therefore, we need to determine this area. Okay? So, ganun ulit. Stress times area. Okay, your VU sub P, is equals to your Q sub U, that is your stress. multiplied by the contact area. Yung contact area natin is B by L minus yung region na yan. Minus yung gitnang region na to. So, bali yung shaded blue area, that is C1 plus D multiplied by C2 plus D. So, parang area 1 minus area 2. Okay? So, therefore, your VU sub B is equals to what is our QU? That is 283.33. Your B by L, that is 2.4 by 2.4 minus your yung C1 plus D and C2 plus D, that is 0.7 by 0.75. Okay? Therefore, that your VU sub P is equals to natin calculator natin. Okay? So that is 283.333 multiplied by 2.4 by 2.4 minus your 0.7 by 0.75, you have 1483.248. Okay, so 1483.248 kilonewton. Okay. So, to determine the shear stress, okay, meron ka ng shear load, hanapin mo yung shear stress, ano ba yung mag-cause ng shearing area? This is your shearing area in punching. Yeah. So, basically, parang area 1 plus area 2 plus area 3 plus area 4, or pwede, kunin nyo yung perimeter multiplied nyo sa depth. Okay? So, kunin muna natin yung perimeter. Ang perimeter natin, which is denoted as B sub O, okay? Ang perimeter natin, which is B sub O, is equals to 0.75 by 0.7 times 2. That is 0.75, 1.45, that is 2.9. Tama? Therefore, your tau sub P is equals to the force, which is VU sub P divided by BO times D. And you need to get the nominal, so you need to divide the factor, reduction factor phi. So that is 1483.248 kilonewtons. Divide it to 0.85 multiplied by B times D, that is 2.4 by B sub O, that is 2.9. Ito yung perimeter natin. That, multiplied by 0.35, you get your shear stress. Okay, ang shear stress natin, divide it to 0.85, divide it by 2.9, divided by 0.35, you have 1.719. 1719 kPa, or equivalent siya sa 1.72 MPa. Okay. So let us check if we have 1.72 in the choices. Yes, we have 1.72. Okay, so that is how you solve for the punching shear stresses. Okay, so next, determine the 20 mm bars required for critical moment. Okay, so this time, kailangan na natin isolve yung moment. Okay, so kunin natin ulit yung sukat. According to the analysis of your bending moment under actually loaded footing, the critical dimensions is at the face of the column. Pwedeng dito or pwede rin sa isang side. Pero you will always choose largest area. So, syempre, na-compute na natin saan yung largest area, yung dito. Okay. Ang tip ko sa inyo para ma-determine yung largest area, okay, kapag magkaiba yung size, yung size ng column, piliin nyo yung sides na katabi nung smaller dimensions. Di ba ang smaller dimensions is 0.35? So, piliin nyo yung sides na yun, yung katabi nun, which is this one. Kasi mas maliit yung ipapang minus mo. Kasi 0.35. Okay, so yan. Ito yung critical area or yung critical section for your moment. Okay? And pwede natin siyang i-consider as a cantilever strip, di ba? And ang cantilever, if you recall, okay, ito yung ating dimensions. Okay, ang sukat nito class is 0.675 and we have a distance 2.4. Okay. So ito siya. Ito yung 0.675. 0.675 and a depth D which is equals to 0.35. Parang cantilever lang to, di ba? Meron kang uniformly distributed sa ilalim which is equals to your Q sub U times the length 2.4. Kasi itong Q sub U mo is in kPa. So, kailangan mo ng away from your monitor para makompute mo yung load per linear meter. So, that is 283.333. So 283.333, multiply it by 2.4, you get your 679.99. Okay, so 679.999. Okay, then to compute the length, okay, so parang ganito siya. So the moment is equals to, that is your M sub U, okay, is equals to your U sub U times L squared should be W. Okay. So, ito yung WU times L squared over 2. Okay? Therefore, your MU, so alam mo na yung linear meter, that is 679.999. Multiplied it by the L, which is 0.675. Since cantilever nga, di ba? Yan yung assumption. So, that is 0.675 multiplied by the centroidal distance, 0.675 over 2 or WL squared over 2. Therefore, your moment is equals to multiplied by 0.675, okay, squared divided by 2, you get your 154.912. So 154.912 kilonewton meter. Okay? So yan yung ating ultimate moment. So parang ganito lang din yan eh. Yung Q sub U mo, multiplied mo doon sa contact area sa ilalim, which is 0.675 by 2.4. So pag minultiply mo yan, that is already in kilonewton. Okay, that is already in point load. So may point load ka na dito. So kunin mo na lang yung centroidal distance, ganun lang din yung nangyari. Okay, so pwede rin naman ganyan yung perspective mo, pwede rin yung ganito yung perspective mo. Okay. So ito na yung ating MU. Okay. And if you remember how to solve for AS, kailangan nga natin guys is number of 20 mm bars. So if you remember how to solve for MU, how to solve for AS sa reinforced concrete design given MU. Okay. Diba ang pinagawa sa inyo, if you recall, ASFY solve for 0.8 compare it to 0.85 F prime C AB. Solve mo yung C. Pagka-solve mo ng C, gawin yung ASFY D minus A over 2 then equals to MU. Ganyan ba yung approach nyo sa reinforced concrete design? Tama ba? Tama no, ganito yung binigay sa inyo na approach. Okay. Pero may mas mabilis dito. Okay? Pero kailangan mo lang i-check syempre kung mag-yields ba siya talaga siya or hindi. So sa footing kasi always yielding yan. So kasi masyado siyang malaki yung width P. So meron tayong derived equation which is mu is equals to phi rho Fy b d squared 1 minus 0.59 rho Fy over F prime C. So yung ibang reference that is equals to, di ba, if you recall, rho Fy is equals to omega F, yeah, tama. Rho Fy is equals to omega F prime C. So minsan yung ibang reference that is phi omega F prime C BD squared 1 minus 0.59 omega. Okay. Some books, ganyan. Okay. So, since kailangan ko naman ng rho, so itong isa na lang yung gagamitin ko. Yung una. Okay. So, yun yung mabilis na way to determine yung still ratio. Okay. Yung AS after the from the MU. Okay. So, mas mabilis yan. So, kunin mo to, 154.912 kilonewton meter. So, convert natin siya to Newton millimeter. So, that is times 10 raised to 6 equals to 0.9. Then, compute your rho. Compute your Fy, which is, ano Fy natin? Fy natin is 275. Okay. So, now, kailangan mong i-determine what is your B and what is your D. Okay. Merong way na pwede mong i-consider 1 meter strip, pwede mong gawin, consider 1 meter strip, okay lang din yon. Or pwede mong gawin, consider mo na yung whole length ng beam mo. So kung ito yung beam mo, for example, ito yung beam mo, so kung nag-cut ka ng section dito, okay, nag-cut ka ng section dyan, tama ba na ito yung makikita mo? Ito yung 2.4, ito yung width, yung depth, D. So parang ito yung cross-section ng beam mo. Kapag nag-cut ka dyan, yan yung cross-section ng beam mo. So parang ganyan lang din yung gagawin mo. So that is 2,400. Then your D is 350 squared. 1 minus 0.59. Rho unknown, Fy is 275 over F prime C, which is 20.7. Okay. Then using your shift solve, you can determine your rho actual. Okay, so let us try. Shift store to A. Okay, so meron tayong moment times 10 raised to 6. Okay, equate it to 0.9. Then unknown x rho. Okay. Then 275 multiplied by 2,400 multiplied by 350 square. Okay. Quantity 1 minus 0.59 rho Fy. Okay. Rho Fy, which is 275. Okay, times 275 divided by 20.7, which is equals to okay, so shift solve. So magtatanong siya nung solve for x. So ang gagawin nyo, mag-i-input kayo ng value para mas mabilis. So 'di ba yung rho is always less than 1.0. So pwede yan minsan 0.001, 002, okay. So try mo na lang 001, yun yung starting point mo. Okay? So therefore your rho actual is 0. Yung rho actual natin 0.00209. Okay? So yan yung rho actual mo. Okay? So if you recall, kailangan pa natin i-check yan sa rho minimum, 'di ba? Rho minimum. So kulang na tayo ng isang page. So dagdag tayo ng isang page. Okay. So kulang pa tayo ng, kailangan na lang natin siyang i-compare sa raw minimum. So if you recall, okay, ibalik natin dito. Raw actual is equals to 0.002, 0.00209. And di ba meron tayong dalawang raw minimum? Okay, yung raw min 1 is 1.4 over Fy. This is for FC prime that is less than 30.36, I think. And yung raw min 2 is equals to square root of F prime C over 4Fy. Okay? So check na lang natin dalawa. Pero hindi ako nagkakamali, I think ano siya square root of F prime yung F prime C dito is let's try. So 1.4 equate natin, cancel natin yung Fy, equate natin sa square root of X. So 30 tama ba? 1.4 over Fy. May over 4 pa. So 4. Yan, so tama nga, 31.36. So ito yung if your F prime C is less than 30.36 and others. So pero i-check na lang natin yung dalawa. So 1.4 divided by 275, that is equals to 1.4 divided by 275, 0.005. And yung isa, square root of 20.7 divided by 4 divided by 275, you have 0.004. So 0.004. So therefore, compare your actual to raw min 1, raw min 2. You will use the maximum. Therefore, you will choose raw min 1. Ito yung minimum. Ito yung mag-govern. Okay? So therefore, kung iyan yung governing, yan yung dyan tayo magko-compute ng number of bars. Okay? So therefore, your N is equals to AS over BD, right? Whereas, bakit AS over BD? It should be AS over AB. Then your AS is raw BD. Okay, divided by AB. Ano yung raw natin na governing, which is 0.005, multiplied by your B, which is 2,400. Your D, which is, ilan yung D natin? Total depth D, 350. Divided to, sabi niya is 20 mm daw. That is pi over 4 times 20 squared. So therefore, your N is equals to, I think ito ay 13 eh. So 0.005 multiplied by 2,400 multiplied by 350 divided by 0.25 divided by pi divided by 20 squared. So 13.36. So 13.369 pieces. So wala namang ganito. So you will round up to 14 pieces. Okay, so this will be your answer. Yan. So may question ba ka class for moments and shears? Okay, ano yun?
Dun sa ano sir, sa 0. Ano po, ba't hindi po yung 1,000 yung ginamit sir? Sa ano po, simula po ng moment.
Wait lang, balik natin. Okay, saan dito yung moment?
Ito po yung may plus, sir.
May plus.
Di ba po, D plus ano po yan? Depth plus 0.75, 675 po.
Ito. Hindi Kung babalikan natin yung drawing.
Hindi po yung sa drawing po kasi hanggang doon po sa columns.
Oh, tama ka nga. 1.025 na to. Okay, thank you. Oh, should be tama. It should be 1.025. Therefore, your moment is pa-compute naman ang moment. Okay, so ito is dapat ito 1.025 to. Okay. 7.999 1.025 squared over 2. 357 pala siya. So 357.212. Okay, then this one, palitan mo ng 357.212. So, buti nakita mo. Times 10.212 times 10 raised to 6 equals to 0.9 alpha x. Ito wala nang equals. Multiplied by 275 multiplied by 2,400 multiplied by 350 squared. Okay. 1 minus 0.59 alpha x. Okay. 275 over 20.7. So shift solve. Okay, 0.01. Okay, so dapat above pa pala siya sa row minimum. Okay, so this is 0.00511. Okay, tama ka. Should be raw actual 0.00511. So kung i-compare natin siya dito, this is 0.00511. Okay? So therefore, yung mag-govern pala is not this one. Ang mag-govern is ito. Okay, then kung 0.511 also almost 14 pieces pa rin. Okay, so 0.00511 multiplied by 2,400 multiplied by 350. Okay, so 4295. Divide it to 0.25 by divided by 20 squared. You have 13.674. So almost the same. 13.674.
Thank you po, sir.
Okay. So still 14 pieces pa rin. Okay. So ito gagawin ko na lang tong assignment. So next week ang duration nito until next week pa rin naman. So assignment na lang to. Okay, may questions pa ba kayo dito? Medyo nagkaroon tayo ng okay, may gusto pa kayo clarify for the for this one? Sige. For your assignment, a column for 50 mm squared with compressive strength 27.65 FY 345.58 support sa dead load 1,000 and a live load of 780. Yung allowable soil bearing capacity nyo is 240. The base of your footing is 1.5 below the grade, and assume a weight of the soil and the concrete to have an average unit weight of 19.7. Okay. So the total depth of the footing is 550 millimeters with an effective depth of 475. Okay. So sagutan ko na lang siguro muna yung number 1. So hindi pa natin to na-discuss yung number 1. Okay, yung number 1, determine the required dimension of the footing. So yung to determine the required dimension of the footing, if you recall yung discussion natin nung una, required dimension. Okay? In your required dimension, dapat unfactored load 'yon, 'di ba? So kung ang unfactored load meaning yung dead load mo should be added to your live load, walang factor which is 1,000 and 780. So 1,000 plus 780, you have 1,780 kilonewton. Okay? Now, 'di ba ang dapat for the required area, dapat ton ay dead load plus live load over QE, or pwede rin yung area is equals to dead load plus live load over 1.33 QE kapag may wind or lateral, and yung isa ay A equals to dead load plus live load plus E over 1.4 divided by 1.33 QE kapag may earthquake. Okay, pag may lateral, pwede mo increase ng 1/3. So, saan yung ang ating loadings lang is dead load and live load. So, meaning, dito siya. Okay, ito lang yung mag-govern is 1. So, therefore, our required area is equals to 1,780 over QE. So, what is QE? QE is yung effective, di ba? So, if ito drawing natin yung ating foundation, sabi dun sa foundation natin, that is 1.5 meters. Ito daw yung 1.5 meters. Okay? So, ito yung NGL. Ayan. Okay. So, ang binanggit niya dito, class, is average na daw ng concrete and nung soil yung 19.7. So, hindi niya na pinaghiwalay yung unit weight ng concrete at unit weight of the soil. Sinabi niya average, take the average of your concrete and soil, which is 19.7. Okay? And wala namang surcharge. Okay? So if you recall your QE, dapat ang pinaka-concept ng QE is kung ano yung matitira na siya lang yung matitirang soil pressure, soil bearing capacity na tanging ko kontra lang dun sa sa load PU. Okay, yung dun sa actual load PU. Kasi yung iba nabawasan na dahil dun sa actual site conditions. So, therefore, that is QA minus the gamma average minusan mo ng, multiplied mo ng height. So, that is 1.5. And wala ka namang surcharge load, di ba? Wala namang surcharge load. So, no need to include your surcharge load. Okay? So, therefore, ito na lang yung matitira. Ito yung net. Okay? And there, it should be QA. So, yung QA natin is 240 kPa. So 240 minus 19.7 times 1.5, you get your 210.45. Okay? So ito, ang ilalagay mo dun sa Q sub E. So therefore, 1,780 divided by 210.45. So that is, anong area natin dito? Okay. So that is 1,780 divided by 210.45. So 8.5 458 square meters. So according to the problem, ang footing daw, okay, sinabi ba kung square siya? So hindi naman binanggit kung square yung gagawin ko. But for simplicity, wala ka namang binigay na restriction kung ano yung width or yung ano yung length. So we can use square footing. So L squared is equals to A, di ba? Therefore, your L is equals to square root of 8.48, 8.458. So yung square root ng class is 2.9 meters. Okay? So that is your length L. So meaning yung answer natin, L by L natin is the dimension of the footing is 2.9 meters by 2.9 meters. Okay? So ito yung ating final answer. Okay. Okay. So that is how you solve for the required area. Okay, so sulat ko na lang dito yung answer so you can verify your assignment. So for two-way or punching shear stress, that is yung actual is 1.64 MPa. Nominal one way, that is 0.6 MPa. So required moment is 705.3 kilonewton meter. And your required number is 11 bars. Okay. So, ayan. Do you have questions? Okay. Sige class. So thank you for listening and so maybe wala tayong pasok on Friday. Okay, wala tayong pasok on Friday. Okay guys, so thank you.
Thank you, sir.